Okay, so let's continue our journey over the Python notebooks. So the next one is going to be Pandas library. So this is our notebook number 3, and we're going to work with Pandas. And what is Pandas? We already covered what is NumPy. Now we're going to move on to Pandas. Okay, so basically the topics that will be covered is what is Pandas series, what are data frames, how to handle missing variables, what are the operations that we can do with the Pandas library, and how we can import data and export data into a CSV file and things like that. Okay, so this is going to be an important one. So again, so far, number 1, 2 were also important, but this is the most important. So because the data sets that we're going to work with for the course usually come as a data frame. So then we need to know how to handle data frames, right? So I want you to pay a specific attention to this one, as it is one of the most important ones. And Pandas specifically is a very powerful library. If you work with R, it's something like dplyr package in R, which helps you to play around and manipulate the data frames over rows and columns very fast. Pandas is doing the same in Python. Okay, so let's start with series. So what is Pandas series? And from now on, we're going to keep adding up to the libraries that we're going to use for the course. So for example, at the end of the day, you will see me adding 6, 7 different libraries, and then give each of them an initial. And then throughout the Jupyter notebook that we put together, we're gonna use call those libraries, right? So we're gonna import NumPy as NP and Pandas and PD as PD. So this is a convention. We're gonna stick to that convention. So if you want to copy from other people's code online, you will see that they use pd dot something. You realize that PD stands for Pandas library. All right. Okay, so let's again start with a list, and we're going to transfer that list to a Pandas data series, right? So my list is 1, 2, 3. Let me actually separate the two. So this is my list 1, 2, 3, and I can take a look at this list actually. My list. All right, and I can transfer this list to a Pandas series, right? Again, series are very similar to NumPy arrays. I should have read this one. The difference is that series can have access label, and meaning it can be indexed by a label instead of just a number. So again, do you remember we had dictionaries, and dictionary we could call the values of a dictionaries by their keys. Series have some concept similar to that. It means that you can not only call the variables in a series by their indices, you can call them by their names, right? So if I change this list to a series, so the output is going to be something like this. By default, the name that's going to give it is going to be equal to the indices. So 0, 1, 2, these are the names of the values, 1, 2, 3. I can change those labels, right? I can say, okay, let's make a label. This is a list of labels, A, B, C. And now that I'm making my Panda series, say, okay, data is my list and index are the labels. Now let's look at that. You see, I have A, B, C, 1, 2, 3. So this is not part of the data. I want you to realize that this is not your data. This is the label of the data. The data is simply 1, 2, 3. Okay. Now you can, so we transferred a list here. We transferred the list to a Panda data series. Now we can do the same thing with an array. So let's say I have an array of 1, 2, 3. I can make it a Pandas data series. Same story. All right. I can make a dictionary to a data series. So if I transfer dictionary to a data series, it's even easier, because dictionaries, they already come with a key, right? So the key, let's say key is A, and the value is 1. Key is B, value is 2. Key is C, value is 3. If I pass this dictionary to a data series, automatically it's going to take the keys as the labels, right? 1, 2, 3, A, B, C. Then and basically this is making the data series out of the dictionary. Now I have my series as this. I can now extract information based on two things, based on index number and the label. So this is the advantage of Pandas data series over both the NumPy's arrays and the dictionaries. Remember, in NumPy array, there was no label. So you have to use index. In dictionary, there was no index. You have to use label. In Panda series, you can do both, right? So I can say, give me the first elements, index 0, or give me the elements which label is A. Again, the answer is 1, right? Now, that was series. We're not going to work with series. We're going to work with data frame, which is a collection of series, right? So data frames are directly inspired by the R programming language and are the workhorse of the pandas, right? Data frame, again, it's very similar to the dplyr package in R. Okay, let's set the seed. We are going to set the seed to 100. And you can do this if you want to see the exact same numbers as I do on my notebook, right? Let's quickly make a data frame. So let me actually stop for a moment. Let's say we have a, remember I imported pandas as a PD. If I do PD dot, there are, and press tab, there are tons of things. You look at this scroll. There are tons of things that I can do. I can call out of this PD, okay? So one of them is PD dot data frame, and it is case sensitive. So capital D, capital F. If I do PD dot data frame, it starts making some data frame. Let me actually pull up the contextual helper. It says that, okay, you're constructing a data frame. You have to pass a data, you have to pass an index, you have to pass columns, and that's pretty much it. These are the most important ones, but by default, all of them are none, right? If I just open close parentheses here, it's going to generate nothing, an empty data set, right? So then I'm going to say that, okay, let's pass the data. I'm going to say data is equal to, let's say I'm going to generate a random number from random integer, let's say from normal distribution 4 by 4, right? If I run this line, so what do I get? So look at that. By default, I get a 4 by 4 nice table, right? This is a data frame. The name of the rows, however, it's basically the indices 0, 1, 2, 3. The name of the column by default, because I didn't pass anything, it's going to be 0 to 1, 0, 1, 2, 3, and etc. Right? So I'm going to say, okay, that was my data. Let's pass the index. You see, we have an index here. Let's pass the index. We want to rename these things, right? And for the index, I'm going to say that, okay, index is equal to, actually, I can do something like this. I can pass a list of A, B, and C, and D. So this is a quick trick that we can do. Well, actually, let me show you what's the output, and then we do the trick. So when I run this line, look at that. The index is going to be A, B, C, D. Instead of typing things like this, I could have used the split function, which is going to make my life a lot easier. I could have done something like this, say, okay, take a string, A space B space C space D, and then call a split function out of that. The answer is going to be the same. Here, it was only 4 letters, and maybe that was not that difficult to just type them as a list, the way that I did it here, right? It wasn't that difficult. But imagine we have hundreds of them, so and you have to add 200 of these things, little things. So it's going to be a lot easier if we use this split function, okay? And so we have the index now. Let's finally add the columns. So for the columns, I'm going to do the same. Actually, let me go ahead and erase this one. Let's look at the one we have here. Okay, so this is our data. Let me actually go ahead and type in data. If I don't type in, the first element is data, the second element is index, the third element is column by default. But for beginners, I encourage you to write data is equal, index is equal, and column is equal. And I'm going to give the column some names, WXYZ, and then split it. Okay, so here's our data frame. A, B, C, D, name of the rows, WXYZ, name of the columns, and this is a random number 4 by 4 matrix inside it. Okay, now I have a data frame, right? I call it df. Sorry, I call it df. Now let's see what can we do with that df. Let's go ahead and see what are the objects, what are the methods. So again, there are tons of methods that we can call, but the ones that are more important that we're going to use for the course are the ones that I list here. So the first one, the most important one, is describe. This is like a summary function in R. So basically, give me the description. Give me the description of the data, right? So it says these are your variable names, right? Guys, remember, at the end of the day, the rows are the number of observations. The columns are your variables. So for example, this can be age, this can be education, this can be gender, and etc. Right? You want to get a summary statistics on the columns, right? How many of them are there? What is the average? What is the standard deviation? Mean, max, first quartile, second quartile, or the median, third quartile, right? So we can have some like this. I can transpose this. Sometimes it is going to be more helpful to transpose this matrix, because imagine I have, I don't know, 200 variables, and definitely I cannot afford to see the 200 variables in columns, right? It's going to be a lot easier to see the 200 variables like this, right? So that's where the transpose function is going to become handy. All right, then let's actually stick to that transpose version. Okay, then we can look at the information. So this is a function that we also call a lot, because we want to see what is the type of data sets, what are the type of variable objects in my data set. I call it information out of it, right? So when I say info, it says that, okay, your first variable W is a float, second variable, third variable, fourth variable, they're all floats. These are numbers, right? And then, so I already called the transpose down there. So let's erase this one. So here we have the transpose. So either if I use .t or just write .transpose open close paren, I'll get the same results, right? Okay, indexing and extraction. This is extremely important. I want you to pay attention. This is something that I expect you to know, because it's going to help you a ton when you're doing your homework and any kind of project in machine learning. So from this part of the, I think from this, again, as I said earlier, this notebook number 3 is the most important one. I want you to, if you're reviewing the rest of them only once, review this thing 3-4 times. All right, then we can, as you can guess, if I want to only let me actually show you the data frame. So this is my data frame. If I want to extract only the first column, the variable W, right? I can go ahead and say df open close bracket and then pass the name of the variable. Okay, that's simple. If I use 2 brackets, however, this is going to be different. So what's the difference between the two? The numbers are the same, but the second one, if I use 2 brackets, it's going to be a data frame. The first one, this is going to be an array. So this is really important, right? Again, sometimes we will get an error, says that this function does not work with data frame. You have to transpose it, transform it to an array. Just remember what's the difference between these two, okay? And now I can easily select 2 columns. Let's pass W and Y. Okay, if I do W and Y, it's going to show me only W and Y. I can make a new column, call it df new, right? And then say, okay, this new column is a summation of column W plus column Y. Look at the data frame. Okay, this is my new column. If I add W and Y, I get to this point. Minus 1.6, minus 1 point, almost 2, so 2.8, minus 2.8. Now, what are the functions that at least we use for the course out of a data frame? One of the most useful ones is drop. Imagine you want to drop a row. Right? I want to drop row named A, the first row. If I want to do that, I have to pass the name of the row here and access. This is really important. Look at the documentation for drop. What is access? By default, it is 0. It means that if I do not type anything here, by default, access is 0. And what does access 0 mean? Just to scroll down and see what does access mean. So 0 or index, 0 means index, 1 means column. So if I say access equal to 0, it's going to go ahead and drop this one from access from the rows. If I say access equal to 1, it's going to go over the columns and look for the letter A. So if I run this line, what do I get? I'll get an error, right? Let's scroll down. What's the error? A not found in an axis. What is the axis? 1. 1 is column. There is no column A. However, if I change the axis to 0, I will not get an error. This row is going to be dropped. Let's look at the output. See? Then I'm going to go ahead and drop the new column from the data, right? Axis is 1. Now, you thought that we already dropped column row A and column new, right? If I call this data frame again, wait a minute, didn't I drop A and new? The answer is yes, you did, but we did it temporarily. If you want to do it permanently, we have to add it another feature, which is in place. If I do in place is equal to true, let's go down and see what is in place. It says that if true, do operations in place and return none, right? So basically it's going to replace my new data frame, the old data frame with the new one, right? Which doesn't have A and column new, right? Let's do that. And now let's call the yeah. You see, there is, I'm sorry, I only dropped the column here, the new column. There is no column named new, right? All right, so that was how we use drop. This is something very useful when you're going to train and test our data. We want to split the data into train and test. We're going to use these things again and again. Okay, what else? We can select a row by calling its label or by selecting it based on its position instead of label, right? So for that, we're going to use the lock. This is location, okay? If I do df location A, it's going to basically give me the values for row A, okay? Give me these values, X, Y, W, X, Y, Z, okay? I can say, give me the location and then the location number. So what is the location number of A? 0, right? It's going to be the same answer, okay? So again, if I use lock, it's by name. If I use ilock, index of the location, it's by number, okay? Then if I don't use anything, by default, it's going to be the column, okay? There is no column A. So for example, if I do something like this, I'll get an error because there's no column A. However, if I do this, if I do column W, I'll get a column W, right? However, here we're talking about rows, again, using location and I location, index of location. Okay, now that I know what does ilock do, so I can pass a range, right? Say, okay, give me a range from 0 to 3, not including 3, and then give me those rows. So what is numpy range 0? Sorry, numpy range 3. It's 0, 1, 2. So row 0, 1, 2. The answer is going to be this one. Okay, let's see if we get the same thing. See, 0, 1, 2. And then finally, this is the most comprehensive version one. If I use the lock function and I pass basically two lists, the first list, comma, second list. Do you remember I think in matrix extraction, we talked about it. The first one is rows. The second one is columns. Okay, so basically I'm telling Python that give me the rows A and D and the columns W and Z, and that's it. This is my extraction from a data frame. We can do conditional extraction. So here, let's remind ourselves what is the data frame. So this is our data frame. So let's extract the numbers that are greater than 0, right? So if I do something like this and I pass it to data frame, it will does the job for me, right? Basically says that in a data frame, only give me the values that are in the data frame and greater than 0. So basically for this one, it's going to be NA, this one NA, this one NA, this one NA. This one, well, 1.47, NA 1.2, 0.01, and etc. Right? So this is what I get. Do you remember we couldn't do something like this with a list, but we could do something like this with a NumPy array. So you may guess that the Pandas data frame is basically built based on NumPy arrays, so that's very powerful. All right. Okay, then we can be more specific. We can say, okay, look at the columns, look at column Y, and show me the output that in the output the column Y is positive, right? So look at that. Well, let me just make sure that I'm telling it correct. Yeah, Y is positive. So here, if I run that, this is negative, so it's going to be erased. This row, this is negative, it's going to be erased. So I'm going to end up with only this row B and D. So let's do that. I'm sorry. Only B and D. The reason that my previous version was some other numbers because the seed number was different. So we changed the seed number so I get different numbers. Okay. I can be even more specific. I can say that, okay, off of that, the data frame above, only give me the X variable. So I can use another bracket and then pass X. Okay. I can say, again, be even more specific. For the y's that are greater than 0, give me y and z. Give me y and z. I can use an AND operator. Okay, so here's a little confusion. Do you remember in Python basic course, we talked about and or? We say for and, we simply use and. For or, we say or. Okay, if I do and here, it's going to complain. Okay, basically it says that the truth value of a series is ambiguous because we're using series in a data frame. And for whatever reason, the author of the package decided to use this symbol rather than and. Okay. You will see some of these inconsistencies and in Python, but again, it is what it is. It's open source and it's being developed over time. So we cannot keep track of every original versions, right? Uh, and the switching cost is expensive. Remember, I think it was back in 2020 that they expired Python 2. It has a huge cost. Lots of companies has to transfer to Python 3, and so the moving cost, the switching cost is huge. So that's why they don't want to, for example, change this one to an and, because if they do that, there are millions of records of codes written in many companies. They're using and, so they don't want to go back and figure out what's missing, right? So here I'm going to say that z is less than 0.5 because negative 0.5 we don't have. Okay. Again, make sure that you go over these things because these are important conditioning, and you should know how to do that, how to play around with these things. Okay. Okay. Another thing, function is head and tail. We're going to talk about head and tail later on, but well, actually, let me do it now. So this is my data frame. If I say give me the head of the data frame, only the first 2 rows, okay? Give me the first 2 rows. Give me the tail, the last 2 rows. Give me the tail, C and D, right? So that's how the head and tail work. Now let's talk about missing variables. And let's make a data frame together. I'm going to make a data frame based on the dictionary, right? There's a bracket of the dictionary. This is key. Why am I using dictionary? Because when I pass a dictionary to a data frame, by default, the key values are going to be the name of the columns. And index, I can specifically tell what are the index, but because they're just numbers, I tell them 0, 1, 2. Let me actually play around with that. So I'm going to say this is my dictionary, and I have a number 1, 2, and an NA, number 5, NA, NA, 1, 2, 3. So let's look at the data frame. So this is my data frame, okay? And I want to see if there is any missing value in this data frame. One of the functions that I can use is called isNull. If I do df isNull, basically I'm asking Python, do you see any null here? So is this null? No, 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 yes, no, yes, yes, no, right? So true, true, false, and etc. Okay, so this is how I can realize for the null values. But this is not the best way because remember, imagine you have thousands of or millions of records of data. You cannot go over the data frame. You cannot visualize the data frame per se. Okay, but there are ways that we can summarize. So for example, I can say, give me the sum of these nulls. Okay, in your A row, in your A column, there's 1 missing value. In your B column, there's 2 missing values. There are 2 missing values. In your C column, there is no missing value, right? So again, there are ways to efficiently use this isNull function. Okay, imagine you found the NAs. What do you want to do with them? You want to drop them, right? So let's drop the NAs. Look at the documentation. What do we need for drop NA? So there's access. This is really important. Access 0 or 1. And again, 0 is for index, 1 is for column. 0 is for rows, 1 for column. So by default, if I do not pass anything, it's going to go over rows and drop any row with an NA. So it's going to row 1, it's okay. Row number 2, there's an NA drop. Row number 3, there's an NA, will be dropped, right? Again, there's going to be, so I see only first row. However, if I change the access to 1, now it's going to do the same job by column. So column A, there's an NA, will be dropped. Column B, there's an NA, will be dropped. Column C will not be dropped, right? Because the access is 1, okay? Now, imagine you found those NAs. What do you want with those? What do you want to do with those NAs? I want to fill them with something. I want to fill those NAs. For example, in this data frame, I want to fill all those NAs with some string. I call it new value. See how easy it's done? So it's going to replace all those NAs with your new value. This new value can be anything, right? It can be, let's say, whatever, whenever there's an NA in your data, replace it with 0. This is not the best way to do that, but let's say for the sake of argument, you want to do that, right? Okay. New value, whatever. Okay. Now, let's see what is a better, for example, what is the best proxy for filling out the NAs? One good number is the average, right? So for example, these are numbers, right? I don't know what is this number. I'm going to fill this number, this NA, with the average of 1 and 2. So basically, I want to see 1.5 here. And here, because the average is going to be 5, so 5 for the rest of them, right? So let's do that. So let's see how we can do that. I'm going to say for column A, specifically for column A, if there is any, let me actually show you data frame. So for column A, only in column A, fill the NAs. There is only one NA. With what? With the average of that column. Guys, remember, if I only copy and run this one, I get 1.5, right? It's dfa.mean. By default, it's going to drop the NAs and then give you back the answer. So the answer is 1.5. So I'm going to say that fill those numbers with this for me. Okay. Okay. So it's 1, 2, 1.5. Okay. Again, sometimes when there's missing values in your data set, you want to replace them. Okay. Now let's move on. Let's see what are the operations. Let's make a new data frame, call it df. And again, these are, I pass a dictionary. Imagine I have 2 PJs by mistake. The observation number 1 is just repeated. So these are the names and GPAs, PJ, TJ, NJ. So these are the GPAs, 4, 3.8, 3.5. Let's look at the head of the data set. Let's look at the tail of the data set. Now, there's a very useful function called unique. And as you can guess, it's basically telling me, give me the unique values of a column. I want to see the unique names, right? The unique names, PJ, TJ, NJ. I want to count the unique names. So I say n unique. Okay. How many unique GPAs do I have? 3. Let's go back. 1, 2, 3, right? In the column GPA, how many unique? So if I change it to names, how many unique names do I have? 3, right? So in GPA, it is 3. Now, this is one of the most useful functions in the data frame. We're going to use it a ton, especially when we're dealing with categorical variables. So we say, OK, df names, look at the names. Tell me the value counts. OK, so tell me the value counts of all those rows, right? It says that there's a PJ, and that PJ is counted twice. Okay, look at the name column here. The PJ counts twice, and then there's a TJ once, there's NJ once, right? So this is really, really useful function. Okay, basically, its value counts. Then we can apply a function to a column. So this is, we already have seen this before. What is the average 3 point, for example, of GPA? For example, we can say, what is the standard deviation? Then round it up to 2 decimals, so 2.24. And now let's say I want to add a new column. I call it GPA 100. And I want to take the GPA and multiply it by 25. Because if I multiply it 4 by 25, the answer is going to be 100, right? So I want to basically transfer this GPA to a GPA out of 100. So I'm going to say that take this column, apply a new function to that. Do you remember? I have to pass a function here. Because I'm not going to use this function anymore, so I'm going to use anonymous function using lambda. I say, OK, apply this anonymous function, lambda x multiplied by 25. Again, this can be anything, guys, right? This can be y, this can be z, whatever. OK, so here's how we mutate a new column in a data frame using a lambda expression. OK, then if you do df columns, you see the name of the columns. So the name of the column is names GPA, GPA 100. If you just do df index, you will see the indices, A, B, C, D. Remember, these are the indices because we defined them to be that way, right? So if I go back, I define the index to be A, B, C, D. OK. OK. Another useful function is sort values. If I do df sort values, and you see it's asking sort by what? By, I say by GPA, sorted by GPA. And then do you want to do ascending, descending, things like that? Is ascending true or not? So by default, ascending is true. Okay. So it's going to be the ascending. So sort the values by GPA 3.5, 3.8, 4. Okay. Now, what is this reset index? So I'm going to say replace this nonsense index, A, B, C, D, to some numbers. So I said basically reset my index. And by default, it's going to reset it to numbers starting from 0. If I do in place is equal to true, it's going to replace that index for me, actually. Let's see. Yeah, it's going to, so it's going to replace that index. You see, remove this one, replace it with 0, 1, 2, 3, and make a new column, call it index, and put it here. Okay. If I do set it to false, it's going to drop this index, right? And however, usually we set it into false because we're not interested in this index. However, here, in order to show you an example that how can I set index, I prefer to keep it there. So for example, if I say take this data frame df and set index to whatever column you want. So if I pass index, it's going to reset the index to A, B, C, D again. If I pass names, it's going to say PJ, 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 MJ. Okay. I think it's going to complain if I do names because there's no, well, I'll go ahead and do that. Let's do names. Well, it didn't complain. So the index is PJ, PJ, TJ, MJ now. So let's do index again. All right. We're almost done. So now let's rename columns. So this cannot be easier. We are going to use the rename function. And we have to basically just read it like this. You say rename columns, you can pass multiple columns. Here we want to rename one column, right? Say rename GPA 100. Instead of GPA 100, that doesn't make sense. I want to call it normalized GPA. And when I say in place is equal to true, it means that just make the changes to my original data frame. Look at the data head. Okay, so it's GPA, normalized GPA. Okay, conditional mutation. This is super important. It's a little tricky. I want you to pay attention, but we're going to use it a ton if we have to make a new variable in our data set. And there are 3 different ways to do that. One of them is the hardest, and most of the time people use the hardest way because you're not taking advantage of the list comprehensions in Python. So let's do it. Imagine in this data frame, we want to create a new variable called isPass. And it is defined as isPass is equal to 1 if the GPA is greater than 3.5. Again, I'm making up these things, right? Otherwise, 0. So basically, we want to make a new column, call it isPass. So the first person pass, 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 fail, right? Because it's not greater than 3.5. It's we want to be strictly greater than 3.5, right? So let's do that exercise. Actually, for fun, I can make it 3.6. Make sure that there is no confusion. Okay, so let's do it the hard way. First of all, let's filter the data when the GPA is greater than 3.6. So how do I do that? I say, okay, df column GPA greater than 3.6, right? So what's the output? True, 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 false. Not surprisingly, right? True, 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 false. Then now I want to make a new column, right? So I have to make a temporary list. I can just call it temp. Again, this is the hard way of doing that. I don't want you to do it this way, but there are good chances that when you search codes online, people do it this way. Specifically the old school, the people who have learned to code in C, C++, and things like that. And they're used to do it this way. So we're going to say that, okay, for X in this column, okay, and again, this X can be anything, Y, Z, I, whatever, for item. So basically, it's going to go to the df column, the GPA column, and basically go through the lines one by one, 4, 4, 3.8, 3.5. It says that if X is greater than 3 point, we change it to 6, right? 3.6. Then do what? Then add, do you remember we used the pen function? Add this value, we say pass, to your temporary list. Otherwise, just add fail to your temporary list. And then at the end of the day, make a new column and replace that new column by temp. Let's look at the output. So we have an is pass, 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 fail. So this is a hard way of doing that. Okay. Is there an easier way to do that? The answer is yes, using list comprehension. Let's see how beautifully we can do that. We're going to say, we're going to do it all in one line. We're going to say that, make a new variable, call it is pass. How it is defined. Open a bracket because we want to make it a list, right? You say, okay, it is pass if x is greater than 3.6, else it is fail. So far, so good. Now, I don't know what is x, so I have to define. For x, in what? In all the GPAs. You see, we can do it in one line. I call it is pass 2 for you to compare in the outputs, right? So I call it I could have called it is pass 1 to replace the previous one, or is pass no number to replace the previous one. Okay, and this is the similar function if you want to do it in R. You know, in R, I'm a big fan of dplyr package and the mutate and if else function. So this is going to do the exact same job in Python. All right. Is there any other way? The answer is yes. So this is relative. So again, in my opinion, this is the hardest way. This is the easiest way, and this is something in between. But there are times that it's easier actually to do it this way rather than this way. So in one of the when we get to a stock valuation exercise, we're gonna revisit these concepts that we have to use this approach, which is easier. So what do we do here? We're going to say that the answer to this one is going to be based on a bunch of true false, right? Then we say, okay, do you remember what the location does? It goes over those rows that the GPA are greater than 3 point. It says that, okay, for those rows, make a new column is pass 3 and assign pass to that. For these, well, let's say 3.6. For those rows in the GPA column that are less than 3.6, make a new column is pass 3 and assign fail. So the answer is going to be exactly the same. Okay, so there are 3 ways to do that. This is the easiest way. The second way, using list comprehension. And this is also not bad. Specifically for at some point, this is even better than this one. But this is definitely not the best way. All right. Finally, let's see how we can import data and export data from a CSV file. So we can use read CSV function. And for that, let me actually show you. So you have to, I have a GDP CSV file in the same folder. So if I open it up, so it's basically, it has date and GDP, right? Let's import this CSV file as a data frame. Okay, so I'm going to say df is equal to pd.readCSV. Let me actually show you some pd. I can do pd.read. So we can read CSV, we can read Excel, we can read I don't know, HDF, HTML, JSON, you name it. You see this, we can read SQL, we can read this SQL query. Basically, you don't need to have SQL. You can connect SQL or SQL with the Python and use Python only. Again, these are the things that we can do with the read module from Python. So here we're going to do read CSV. And then you have to pass, let's look at the contextual help. Then you have to pass some features, right? As you can see, there are lots of things that you can pass, but luckily all of them has a default value, so you don't need to be worried. So, but the most important one, which doesn't have a default value, is your file path, right? So what is the path of your file? Because I'm in the same directory, I don't need to write, for example, C colon backslash, etc., or D colon backslash GitHub, etc. And if I'm in the same directory, as soon as I type something like this, and then I press tab, it's going to suggest me whatever I have in this data set, right? So here I have GDP CSV, okay? I can go ahead and do that and read it. Let's look at the tail of the data set. So this is the tail of the data set, right? And we can write to a CSV file. So for example, I want to make a new let's CSV file. I say the df dot to CSV, right? So if I do df dot to CSV, well, actually, let me actually show you what two functions we have. We can do to CSV, to Excel, to the HTML, JSON, and etc. Right? The same story. I'm going to go ahead and make a new GDP CSV file, and index is false. When I say index is equal to false, basically I don't want to see this 285, 286, and etc. Right? Okay. And okay, if I run this line, pay attention to the left-hand side. There's going to be a GDP underscore new added to that, right? So let's look at that. See, this is our new CSV file. And when I double click on it, look at that. The index is not 285. Well, that was the tail of it. Well, I have to open it again. But basically, that's what the index false is doing. It's going to remove the index. And we're going to talk about time series in a separate notebook later on, because, for example, we know that this is not a good index, 285, 286, and etc. A better index is date, right? So we have to reset the index of this data frame to date. So this is something that we do in the time series. And if you want to do Excel, let's make an Excel file. Again, we use to Excel. You have to give it a sheet name. Let's say raw data, and then let's generate that one. So this is our Excel file. Well, it doesn't open up here, so we can open it up separately. I encourage you to do it on your computer and see if the sheet name is exactly equal to raw data. All right, that was Pandas library. And Panda library is super powerful. It has a visualization as well, which we are going to cover later on. So for the next 3 lectures, 3 tutorials, Matplotlib visualization, Pandas visualization, Seaborn visualization, I'm not going to go over details because it's unlimited. So depending on what we're going to use for the course, as we move on, and as I need any of these functions, I will introduce them there. However, I'm going to make a very quick video, maybe 5 minutes each, over those things for Matplotlib, Pandas, and etc. But I'll leave the rest of it to you guys. And again, I do not encourage you to memorize anything. Personally, if you come to my office and I say that, okay, can you plot this thing for me? If it is off the top of my head, I can. If not, I Google it. I want you to learn Google and basically how to read codes in Stack Overflow and apply it to your own code, right? All right. So I'll see you in the next one.